Okay, so in this slide, we're going to be talking about simplifying rational expressions that are complex. In number 9, we're asked to simplify the complex fraction by rewriting it as a division problem. The first thing that I'd like you to understand is that when you see a complex fraction like this, which is a fraction over another fraction, that the bar that separates the top fraction from the bottom fraction really means division. So what I've done is I've made that bar red, and that red bar, again, really means division. So I'm going to go ahead and rewrite this as a division problem. R squared over R squared minus 25s squared divided by R over 5s minus R. Now we know that dividing by a fraction is like multiplying by its reciprocal. So now I'm going to write R squared over R squared minus 25s squared times 5s minus R over R. Now the next thing that I'm going to do is I'm going to look for opportunities to factor in the hopes that common factors are going to cancel out. And I notice that on the bottom left I have a situation that is a difference of two squares. R squared minus 25s squared factors into R plus 5s and R minus 5s. Now, in doing this factoring, I see factors that are very similar but not exactly the same on the top and the bottom, and they are the 5s minus R on the top right and the R minus 5s on the bottom left. Those are exact opposites of each other, so I'm going to go ahead and cancel those out. But I'm going to put a -1 in its place. I also notice that the R squared on the top left and the R on the bottom right are going to cancel out, leaving me with just an R. A strategy that I implement is that when I cancel things out, the things that are left over I like to put in a circle just to remind me that they're still there. If I just cross things out all over the place, it can be confusing what's actually left over and what has been crossed out. So as I do a visual sweep on the top, I'm left with two elements, a -1 and an R. So in the end, I'm left with -R on the top. And in the denominator, I'm left with R plus 5s. So in number 9, we were asked to simplify the complex fraction by rewriting it as a division problem, and I think we did that successfully. In number 10, we're given another complex fraction, but this time we're supposed to simplify using what's called the LCD method. First, I just want to highlight for you that this red fraction bar, which separates the top fraction from the bottom fraction, actually means division, which I covered in example 9. But we're going to treat this problem in a very different way, because in this problem they want us to simplify using what's called the LCD method. In the LCD method, we're going to focus on the denominators of our top and bottom fractions. Those include the factors a and ax squared. What I need to do now is select the LCD of those little denominators, the least common denominator of a and of ax squared. And the least common denominator of those two denominators is going to be ax squared. And what I'm going to do is multiply the top and bottom fractions by ax squared. Now let's focus on the numerator only. If I were to multiply c cubed d cubed over a times ax squared, the a on the top and the bottom are going to cancel. So in the numerator, what I'm left with is c cubed d cubed x squared. Moving to the denominator now, if I multiply x c squared d over ax squared by ax squared, the denominator is going to cancel with the ax squared, the a with the a, and the x squared with the x squared. So I'm really just going to be left with c squared dx. Notice how I said that in alphabetical order, which is a good convention to stick with. Now let's look at what remains. The c cubed and the c squared can cancel, leaving you with a c on the top. The d cubed and the d cancel, leaving you with a d squared on top. And the x squared and the x cancel, leaving you with an x on top. So in the end, I'm left with c d squared x. So on this slide, I've given you two different ways to simplify a complex fraction. One is to rewrite the problem as a division problem, and the other is to use this thing called the LCD method. Most students aren't as comfortable with the LCD method as method number one, but the LCD method is actually the more efficient way of doing the problem. It requires a little bit less work, so it's something that you should get used to.